what's going to happen tomorrow?
Spring things
The
happen.
lottery numbers will be, no.
Your bacon number will suddenly go down to 1.
Yeah. I'll be in here from 10 to 11 as usual. So if you've got lingering questions, or if you want to try to nail down that last nagging problem with a PA or whatever, right, feel free to come by. So it's basically like office hours, but mainly for this class. And I got my regular hours, 9 to 10 and 11 to 12. Club meeting at 12 o'clock, spring thing, I don't know when it starts.
It's 10 to 2.
10 to 2? Weather forecast?
Give me
I'm
something.
thinking it's going to be pretty nice out.
I'm thinking.
So you
I
can
was
go.
mostly asking about this class.
Okay.
It's just going to be more because there's no assignment.
There's no assignment. Well, life is an assignment maybe, but
It's supposed to be cloudy tomorrow, high of 71, low of 53.
okay,
So it
it's
should be
good
a nice
for
day.
climbing walls and riding mechanical bulls.
Yeah, and don't need sunscreen.
Yeah. Yeah, so I'll be around, but there's nothing upcoming except the exam.
What's an array?
What is an array?
Let's think philosophically.
Yeah. Arrays are the key to it all.
Only
You
if
can
you've got
use
42 elements.
You can use data to index data.
Arrays of arrays.
Yeah.
Of.
How many bytes is the character use?
That's interesting because I just pulled down a Stack Overflow discussion.
Car size 8-bit or 16-bit.
So is car size 8-bit or 16-bit? And this person says character is 8 bits, that's a byte. And this other person says that's simply untrue. And then he writes back and says, yes, I realize it's Java, I was wrong earlier. So here's the accepted answer. Car in Java is a UTF-16 code. Not necessarily complete Unicode, but effectively a 16-bit unsigned integer. So for example, very limited as to which characters converted with something characters may take 4. So note that text files really have a formal format character set associated with them. Text files will normally be saved in UTF-8, which is 8 bits per character, unless the character is special. So we usually think of ASCII, right? And it's really Unicode, but cars, I believe, are 16 bits to support Unicode. What's your definition of special? Anything non-ASCII? I was trying to keep my answer concise. For a full definition, see Wikipedia. When concise means using such a hideously vague term as special character, I don't think it's much use. So I just grab that because to me it's like my standard interaction on Stack Overflow. What were you saying about characters?
Well, it's only 16 bits if it's UTF-16.
Okay.
Also, it's 1 to 4.
Yeah, 32-bit.
But did you know you can download archives of everything to view it offline? There's a few projects for that.
Oh, really?
So
Wayback Machine.
I chose a bunch of good ones. So if you ever lose the internet for good, I have them.
Okay.
And then there's another program you can use to read them.
Mm-hmm.
And it has to index all of them so you can search through.
Right.
Stack Overflow took my computer a week and a half to index
Wow.
everything.
Yeah, there's a lot of dialogue there. Yeah, web scraping's fun. Wayback Machine is cool. All right, so should we look at the final or the final topics? Let's look at the final topics.
Look at the final, will be pretty neat.
Yeah, it would be. All right, so the heck have we been doing all year?
I don't know.
Yeah. So main things, right? Either writing some Java code, looking at some Java code and answering questions about it, or modifying some code. Okay, so all those things are fair game. Java's object-oriented, so you should know that. We didn't really spend a whole lot of energy about this interpreted versus compiled, but you should know that Java is interpreted, right? It translates, when you compile Java, it doesn't compile to x86 code, right? It's really compiling into some synthetic assembly language, machine language called bytecode. And when you run a Java program, when you say Java class name, you're starting a little virtual machine that interprets that bytecode as if it was machine code. The real punchline for that is on the plus side we get portability, because you're not compiling to a native executable that only runs on this type of hardware, right? You can port the JVM and run this on anything, but the downside is you take a performance hit. So you should understand what object-oriented means, right? This basic idea of bundling code and data. So in a structure, we basically take different pieces of data, we put them together in this struct. With an object, we also throw in code, which presumably has something to do with the data, right? It's not just random code and random data, they're all related. So the elements comprising a linked list plus the code for inserting, searching, et cetera, right? That's a viable collection of things to put into an instance of a linked list object. So information hiding, we use this a lot and we deal with it a lot, but we don't necessarily talk about it a lot. So this is the idea of only exposing the pieces of your class that need to be exposed, right? So an example I like to think about is a stack. So you want to implement a stack package and hand it to somebody. Here's the stack you can work with. How do you implement a stack? You can use an array, okay? And you can start storing from element 0, and every time you push, store at successive locations. And you have a stack pointer which says, where's the next thing I'm going to store? You could also have an array and start with the last element and store things in previous locations as you push. And maybe your stack pointer points to the last thing that you pushed instead of where the next thing will be pushed. Or you could use a linked list and have no stack pointer at all and just always insert right at the beginning of the list and remove from the beginning of the list. That's always the top of the stack. But none of those implementations should change the user interface, which says construct a stack, push, pop, see if it's empty, see if it's full, and so on. So if you're using an array and a stack pointer, you don't want the user to be able to look at those things directly. So you would hide that information, right? If you're using a linked list and you've got a Sentinel node, you don't want the user to be able to come in and look at that Sentinel node, or worse yet, modify it, right? So information hiding is sort of putting that stuff on the other side of the firewall, so that they get this abstract interface. So abstract data type is like, what's a stack? It's a collection of data, push, pop, first in, last out, first in, first out, and so on. So those things go together. So you should know basic Java syntax, okay? If it's stuff that you should have been encountering in your coding, I'm gonna hope that you know how to code it on paper, right? So if statements, for loops, while loops, assignments, comparisons, things like that. I'm not going to deliberately nickel and dime you on stupid syntax issues, right? If you use an uppercase C on the catch statement, I don't care, right? If you use curly brackets around exception E in the case statement, or something like that, right? I'm not worried about that. But public static void main, etc., right? You should have written that, dozens of times by now. So you should know at least what the pieces of that are, right? When you define a method, it's got to have a return type, right? So that's something we've been doing since 2.24 for the most part. So things like that, right? The sort of low-hanging fruit is what I'm mostly interested in. So defining and creating a class is, right? Class, name of the class, curly bracket, stuff, closing curly bracket, right? So you should be able to do that. I don't match parentheses and curly brackets usually when I'm grading your stuff, unless it's critical to the logic, right? So sometimes people throw on like 10 closing curly brackets at the end just to cover their bases. So that's fine. So creating an instance of a class, right? So the whole idea of the new keyword. So we construct by saying rectangle R equals new rectangle. And we might or might not pass arguments to that, so those things are called constructors. And that creates an instance of the rectangle class in that case. Accessing variables and methods from an object, right? Object name, period, name of the variable or method. That's really all there is to it. But being aware that with methods, you have more than just the name of the method, you have the whole signature. So the signature is the name plus the types of arguments. And area, or a method that takes an int, an area that takes a double, two totally different methods. So that's the signature. Public and private, right? Accessibility outside of the class. We talked about that a minute ago. Static versus non-static. So for the most part, in most of what we've done this course, right, the only time you really, really need to use static is public static void main. Okay, you can certainly find other places to use it, but really static is saying I want to be able to access this variable or this method without constructing an instance of the class. So usually the methods in a class have something to do with the data in the class. You have a rectangle, it's got data which is height and width. You've got an area method which uses that height and width to figure out the area, right? But if you wanted a generic area method that you pass the height and width to and it returns the area of that rectangle, right? We don't need to construct a rectangle to run that method, right? It would make no sense because we're passing in a height and a width, so that might be something we would make a static. So math.square root, math.pi, those are sort of classic examples of statics.
You can have static variables, right?
Yes, you can. Yeah, so math.pi is a static variable. And then this keyword, so this is basically, if I'm an object, this refers to me, right? And there's a couple of ways we use that. One is this business in constructors. Where we say something like, so here's a rectangle, we've got a height and a width. So here's a constructor we're passing a height and a width to, and we'd like to set this height equal to this variable. Right, so we can say this. So a bare h without any embellishment refers to whatever is most closely scoped, right? The thing we've defined most closely to this line of code, which in this case is this local variable. It's an argument to the method. But when we say this dot h, right, this is the object that we're inside right now, and so the h field of that is this variable up here. But the other thing we can do with this is if we're creating, say, a thread, and we want that thread to know who created it, we can pass it this, right? Because when we create a thread, we know all about that thread. We're going to say thread t equals new such and such, right? And now we've got this object t that is that thread. But this thread suddenly pops into existence and says, where did I come from? It has no way of knowing, right? So when you construct that thread, if you were to pass it an argument this, the constructor can take that and save it somewhere, and now the thread has a local object that refers to the thing that constructed it. So you can put up two-way communication like that. let's see, where are we? This data structures. Yeah, that's a good thing to know in a data structures course. So different data structures, right? So arrays we know about. Linked lists, so singly linked lists, doubly linked lists, circular linked lists, right? All kinds of different versions of that. And we beat that to death in 222, right? But we wrote some code in Java this term to implement linked lists. And one thing we noted was that we didn't necessarily need a sentinel node anymore. Same with trees. So we did some binary trees. You did decision trees for your 20 questions assignment. And we talked a little about hashes and Huffman algorithms and all kinds of things. So main things that you should know here, right? Basically, you should be comfortable working with arrays, lists, and trees. Don't forget everything you've learned about hashes and tries and all these other things, but I'll concentrate mainly on linked lists and trees. And just go back and make sure you understand how these get coded in Java, okay? And not the built-in ones, right? The ones that we spin ourselves by hand. And tied into this is this idea of recursion. So trees in particular, a lot of the algorithms are recursive. So when you want to do traversal, when you want to calculate the height, when you want to see if it's balanced, there's recursive versions of that. There's also non-recursive versions. So think about those. Generics, we didn't talk about creating generics, I don't think, so don't worry about that. But using generics, right, something like a linked list class from Java is generic in the sense that you can make a linked list of strings or integers or doubles or rectangles or fractions or anything else. So when you construct a linked list, and you put inside angle brackets the name of the class of objects that you want to put in your list. Or if you do a hash, you need two of these things because you can have a key and you can have a piece of data. And those can each be any type of object. So angle brackets when you construct, and when you say new, or when you declare and when you construct. And then it's just like any other class. It kind of stops being generic at that point. If you want to create this yourself, right, we didn't go through it, but it's 30 seconds to learn how to do that. When you define the class, you basically put in angle brackets, the name of a variable, basically. It's almost like a macro at that point. And when you use that variable anywhere, it becomes a synonym for whatever they constructed with. So we can talk about that some other time if you like. But know how to use generics. Iterators. So iterators are another way we can pull information out of a structure. So linked lists, binary trees, we have ways to traverse those, but something like a hash, we don't have an inherent traversal mechanism, right? Now if the hash is implemented in an array, we can make a traversal by using that. We can go through each element of the array, see if there's a piece of data there, but that goes against this idea of an abstract hash, and it goes against our information hiding. So just a plain old generic or abstract hash, there's no natural traversal mechanism. So we use an iterator, which basically lets us pull data out of this hash one piece at a time until it's exhaustively given us every piece of data, typically the keys. And it's a very general scheme. We can have iterators defined for lists, we can have iterators defined for trees, or sets, or any other kind of collection. And we use something very similar to iterators when we do input. Right, when we say scanner.hasNext and scanner.next, that's the iterator structure basically at work. We have something we can use to say, is there any more data available? And then we can have something which says, give us the next piece of data. So look at those. Strings, make sure you know the basic string methods, okay? So length equals compare to toString, character at, and so on and so forth. And the toString method in particular, you want to be comfortable with, right? So what does toString do?
Converts an object into a string.
Converts an object into a string. That's exactly what toString does. It doesn't print anything necessarily. It doesn't do any input from standard in or anything like that. Its main purpose is to convert an object into a string. But it could do other things if we wanted to abuse it, but the understanding of toString takes an object, returns a string that somehow represents that object. Could you have toString print stuff? Sure. Could you have it launch a virus? Sure. It's just a function, right? But it's called automatically whenever you have an object and you're trying to use it as a string. It'll call this to try to convert it. So generally we don't want to do anything other than that. Why doesn't equal equal work to compare strings to each other?
When you use equal equal, it's looking at
Yeah.
kind of place in your memory.
Yeah, it's
Instead of-
basically saying, is this the same object? So here's an object that says hello, here's an object that says hello. Well, this is not the same object as that. So they're not going to be equal to each other. So we have methods like dot equals, string 1 dot equals string 2. That'll tell us, do they have the same characters? So make sure you're comfortable with strings. Arrays. So arrays, there's declaring, and then there's actually constructing. So if we want an array of rectangles, let's say we want an array of 5 rectangles. Well, this will say my stuff is going to be an array of rectangles, but it's really just kind of declaring what I plan my stuff to look like. But it doesn't allocate any place for storing the information about these 5 rectangles. So either on the same line or in a separate line, we can do this. My stuff equals new rectangle bracket 5. And what this is basically saying is there's 5 spots in here for holding references to 5 rectangles, right? But if I try to do something with my stuff bracket 0, I'm going to get a null pointer exception. Because this is creating 5 spots for references to rectangles, but it's not actually creating any rectangles, right? So I need to do something like my stuff 0 equals new rect, possibly with arguments, right? And now this is actually referring to a rectangle. So for arrays of objects, you kind of have this 2-part process. You have to declare the array, right, and set up space for these references, but then you still have to construct the individual elements of that array. You don't have to do that with primitives like int and double and char, right? For those, we can just say integer array data equals blanking.
Which just
Although an array of ints and an array of integers are different.
Yeah, so, and I don't know if we ever really talked about this, but int with a lowercase and integer with an uppercase are kind of different things, right? Integer is a class, and it's just like rect and string and everything else. Int lowercase, that's a primitive, right? And so we can take shortcuts with that. For example, we can say, you know, integer x equals 5. And we don't have to use the new keyword, right? Whereas if we want a string, well, strings are different too. If we want a rectangle, we have to say rectangle r equals new rect, and then give it a value, right? So these primitives, int, float, double, boolean, character, and 2 others I can't remember, we can take these shortcuts with. Otherwise, nobody would use Java, because it would be really annoying.
How would it
would be more annoying.
Because if you wanted to say integer x equals 5, you'd have to say integer x equals new integer parentheses 5.
Why can't you be like Jframe and just make the syntax like into a number? Automatically. Creates it.
Well, yeah, if you did that, but if you didn't have these some kind of shortcut,
I'm pretty sure in your class you can actually do that. You just say integer x equals 5 and it'll work.
yeah.
Yeah.
But if you weren't able to do that,
Oh.
if everything was treated exactly the same
Oh.
as exactly the same kind of class, and every time you wanted to set I equals 0, you had to say integer I equals new integer parentheses 0. I think people might revolt. I don't know.
Coming the next version.
I might
of Java.
revolt. Yeah. It would, to me, it would feel like a big conceptual break from C. So,
Well, if you want to be object oriented, you have to get rid of the stuff that's not objects.
well, yeah, that's true. But maybe people would refuse to be object oriented. Some people
Get rid of the past.
would refuse
Show
to be
the
object
oriented.
oriented. But then this is a slippery slope if you start making compromises. Array length as a field. Scanners. Okay, so scanners and print writers. These are the two main ways we've been doing input and output. There are a lot others, and we didn't get a chance to talk about them. But there's data input streams and data output streams. There's buffered readers and buffered writers, and there's readers and writers, and there's lots of details and nuances for doing various levels of raw versus cooked input and output. For buffering versus non-buffering and so on. But I think everything we've done in here has been through a scanner or a print writer. Okay, scanner for input, print writer for output. Scanners we can construct from system.in, that gives us a handle to standard in, but we can also construct from a file. So we can make a new file, construct a file with a path, and then use that file as a constructor for an argument for the constructor for scanner, and we can ingest from a file. Print writers we can construct with a file, and we can write out to a file that way. We don't need to construct a print writer for system.out because we already have system.out. That's a print writer. So we can use system.out.println and so on. Class extensions, this is another thing we haven't done a whole lot with explicitly, but we've used them extensively. So class new extends old, right? New basically kind of inherits all the stuff that's part of the old class, but it gives you the option of overriding methods, adding new methods. And so we first sort of introduced this in the context of Jframes and wanting to take a swing object, get all the good stuff that comes from that class, but then make some changes ourselves. So we extend some of these base classes. And then super is a way that we can get back to the original class, the class that we're extending. And we use that often if we want to run some of the original code that we've modified in our extended class. So a classic example there is when we have a panel and we write our own paint method. Sometimes we still want to get back to the original paint method because that did things for us like draw the frame, fill in the background, draw the little buttons on the top, and so on. If we still want those things to happen, we don't want to write code for it, we just say super.paint. And that'll run the base class's paint, and then we go ahead and we add our stuff for drawing tic-tac-toe board or whatever. Exceptions and exception handling, so try-catch blocks, we know all about those.
Or just add throws.
Or just add throws, yeah.
Throws exception.
So here's one thing I want to make sure we talk about, though. And I always do catch exception E, but that's not what you always need, right? This is any type of exception that you expect might be thrown. And if that exception gets thrown and matches this, it'll run that catch block. So try some good stuff, catch some sort of error handling stuff, and then some more stuff at the end. So a lot of times we have these try-catch blocks because when we write our code, Eclipse complains and says, it must be surrounded by try-catch, and you say, okay, go ahead and do that. And it writes code for us, and there's a stack trace that usually gets called up here to show you what the error was and so on. Here's what I want you to think about though. Suppose you're trying to connect to a socket. Okay, so you construct a socket up here and try to bind to a port somewhere. And that might throw an exception. The port might not be available. In which case you'll come down here and you'll do a stack trace. And maybe you'll print a message saying, you know, failed to connect to socket. What do you want to do at the end of this catch block? Something like a return, right, usually. And in most cases, when I looked at people's code, at the end of the catch block, they just fall out and they continue with the more stuff, right? And that's probably going to lead you to something like a null pointer exception or some other issue down the road. So keep in mind that when you're writing a catch block, you're really trying to deal with some abnormal event. And ask yourself, what should we do in this catch block? Yeah, we want to print an error message. Yeah, we want to say an exception occurred. What else do you want to do? Do you want to continue processing after that as if nothing happened? And more often than not, the answer is going to be no, we don't want to continue. It's possible that you might want to try something, and if it doesn't work, I don't care, we'll just keep going anyway, right? But that's usually not the case, so more often than not, you might want a return here. So just sort of be aware of that down the road. And Eclipse helps you with this a little bit because sometimes you initialize a value in here and you get an uninitialized value warning, but more generally. All right, so exceptions, exception handling, swings and GUI. So I'm not going to ask you detailed questions about Jframes, about constructing these things, about you know, writing code to put a button onto your panel, things like that. The tools do that for us, right? We have drag and drop interfaces and they generate code, and at some point you may want to learn how to do these things manually if you don't know, but I'm not considering that part of this course, okay? But here's what I want you to know. What is a Jframe, right? It's sort of a top-level container that you can put other components into. Components like buttons and checkboxes and panels and labels and things like that. Panels are useful because we do painting on them often, and that's what I encourage you to use for your tic-tac-toe. If you put a button down there and the user clicks on a button, right, nothing happens by default. But if you go into Window Builder or whatever you're using and you write some code, you can have an event handler called when the button is clicked. And I'm not going to ask you to recreate the code that's, you know, made for you to handle a button press. But you should know that if you have that code set up, then when the button gets pressed, you're going to jump down, right, wherever you are, whatever your program is doing, you're very quickly going to jump down to this section of code. And it's probably going to be passed an argument that helps you figure out why you're here. Okay, so if there's a mouse listener and somebody moves the mouse or clicks the mouse or whatever it's listening for, you'll jump down through basically an interrupt into a section of code. You'll get an argument, which is a mouse event or a button event or some kind of object. And you can use different methods in that object's class to get information about the event. So you can get XY coordinates for mouse clicks and things like that. So if you need to get coordinates of the mouse and you can't remember if it's get X or get X location or it's an uppercase X or a lowercase x, I'm not worried about it, right? But if you have no idea that you can get XY coordinates in here and you try to call a method like find mouse position or something, right, then you're missing something that you should have gotten. So basically go through what you did in your GUI codes and make sure the parts that you had to write make sense to you. And you also definitely want to understand the paint method, right? So if you want to do any painting on, say, a panel, you have to write your own paint method, because whenever that panel gets painted, it calls the paint method. And the paint method sets the background, the border, and stuff like that. if you want to draw a tic-tac-toe board, you've got to make your own version of Paint that says, hey, draw 2 lines here, draw 2 lines there. Okay, so we're overriding a method. And this is where we use super again. If we still want that other stuff, we can call super Paint first. So event handlers, mouse listeners, button listeners, we just talked about. Threads. So threads should be very close to your memory, right? Because you were using them mostly in this last programming assignment. So you can extend the thread class or you can implement runnable. Okay, I want you to at least know how to extend the thread class. But if you implemented runnable on your programming assignment, that's fine. But I wanted this to be sort of another example of a class extension. So new class extends thread, and the main thing you do in this, the main thing you have to do in this is you have to create a run method. Okay, and run is kind of like the main program for that thread. And if something calls that run method, it's just a method, right? It just executes that code. But if something calls the start method on that thread extension, start does 2 things. One, it creates a new thread, starts a new process, and then it calls the run method. So if you call run, you're just jumping to this section of code. If you call start, you're creating a whole new process and then having that new process execute the run method. And that's when you're actually multi-threaded at that point. And as I mentioned with this, sometimes you want to pass this to the thread when you construct it so the thread has a way to get back to you so you can share information. And we talked a little about possible issues, contention and such, so deadlock, live lock. So classic example, 2 resources, each waiting for something that the other process has, and neither one is ever going to relinquish and never going to satisfy its needs. So it's a deadlock situation. So one way to help deal with this is to synchronize your threads. So synchronize keyword lets you control when pieces of code are accessing in multiple threads. So if you're going to do something, you don't want anybody else executing this code while you are, you can synchronize a whole block of code. And then exactly one process will be allowed to execute that block, that set of code. And any other process that tries to execute that set will basically pause until the process is executing finishes that block. And then sockets. So this is also recent stuff, right? So mostly we work with sockets and server sockets. So a server socket is bound to an IP address and a port. A socket says, a socket says connect to this port on this address. And if it finds a server socket there, connection gets established when the server says accept. And then you've got 2-way communication. Get input stream, get output stream, get you things that you can use in constructors, including constructors for scanner and print writer. And from there you can swap information. And there's a lot more going on to sockets, right? So if you code up sockets in C, you see a lot of extra steps that are kind of being handled for you. So you create a socket, you bind it to a port number, you listen for connections, you accept a connection, and so on and so forth. And most of this happens for us when we construct a server socket and say accept. So there's a lot of details that are hidden from us, but be aware of. And then that's part of the general client server model. So PuTTY and CTEC or PuTTY and the Linux server are sort of classic client server. That's about it. So hour 50 minutes on Monday. Hopefully show up on time, close to on time. I'm not putting lines on the pages this time, so you can do your own space management. What? You can bring a ruler, or you can bring a piece of lined paper and put it underneath the page, and that's always fun. So yeah, that's about it. So thank you for this this year. It's been interesting and fun to teach all of you, and to have you here. So I appreciate all of your effort and energy and participation. And I will see you tomorrow and or for the final. And that's about it. And who put in Lonely Void 12 times on their signature sheet? But they're all signed, so maybe it's legit.